Hello everyone. Our team today is presenting using virtual reality and 3D industrial numerical models for immersive interactive checklists. So checklists are used in all phases of product lifecycle management from project inception to service to dispatching. It is important to run through this checklist and see if the functionality is implemented and also to check if there's a necessity to update a certain information. So here in this paper, they're proposing a model which is going to provide a 3D visualization and navigation using virtual reality for these industrial checklists. So we all know that VR is a simulation environment which gives user the feeling of being in that environment instead of the one they're actually in. And virtual reality has gained a lot of popularity in the past few years. If you see the growth curve of virtual reality in here, it's you can see that it's a pretty steep curve. Virtual prototype versus physical prototype. Virtual prototype has become a common practice in industries today because when a product is in its development phase, it would be better to use virtual models rather than real models, the actual models. There are a few challenges faced while using these virtual prototypes during project lifecycle management. Choosing the type of the model to be built, that is, what material to be used for the model, with concerns to appearance. And then mechanical characteristics, which can be something like modulus of rigidity or friction coefficient. And also, the structure of the model is a key question. For a specific task, an appropriate structure has to be designed. Last but not the least, format conversions and compatibilities. They are also another central question. The advantages of using these virtual prototypes would be they help in generating automatic documentation. See, that's what most of the software engineers dislike, right? The documentation. Another advantage is that it helps in involving remote users and data sharing. Say, for example, we have a scenario where there is a mixed teleconference with remote users in a virtual world, and also they're sharing some virtual objects. In such scenarios, we can use these prototypes. Implementing the product lifecycle management that links to this virtual reality, it can be very time consuming. And also the VR systems, they do not focus on all steps of development lifecycle. So the contribution of this model is that it is linking virtual reality to concepts in the industry, and also it's providing a kind of a generic tool for VR based checklists for the steps in product development. So while developing complex products, we need a sort of global scheme that is going to indicate all steps of product lifecycle management so that there can be a step by step checking. There should be a sort of traceability between the steps so that the errors can be detected in earlier stages. So basically, these checklists are made of the tests to be performed during project gate review. Industrial companies, they aim at running as many of the project review checklists as possible using virtual numerical models instead of real models, real prototypes, in order to reduce the development costs, of course. The diagram here, it shows the virtual reality adapted product development cycle. It is inspired from Alstom Transport's product development philosophy that shows a product development cycle. It presents the main development steps, as you can see. The SGR here, it says specification gate review, it's the requirement review. And then we have the PGR, preliminary gate review, which is the preliminary design review. And then we have the CGR, that is critical gate review, which is the detailed design review. and the IQA, which is the initial quality approval, which is the industrialization review. The figure shows how the industrial companies intend to use virtual prototypes to check as many steps as possible. Physical prototypes are used only in those steps where they cannot use the real prototype, the actual prototype. Thank you.